Hi there. So we do a lot of those prefactoring puzzles, where you make the x, and in the top is our c value, so -12, and in the bottom is the b value, the -4. And we're looking for two numbers that multiply to -12 and add to -4. So in this case, -6 and +2. And then that factors out as x minus 6 times x plus 2. So we do a lot of those puzzles and just get at that idea of two numbers that multiply to this, that add to this, which obviously doesn't work when the a value isn't 1. And if we're doing a more difficult problem like this, where the a value is not only is it not 1, but it's not prime, and the last value, the c value, also not prime, we get a lot of different combinations when we're guessing and checking. But I had a student once whose name was Cole Fitzgibbons, so we call this Fitzy's method. He said he does it like this. So he makes that x again. He uses the product of a and c. That goes in the top, so -60 here. And in the bottom, he's at -11 again. And then same thing, he's looking for two numbers that multiply to -60 and add to -11. So in this case, -15 and 4. And then he said, so what I do is I make the parentheses, and I go x minus 15 and x plus 4. And I said, but Cole, the x times x doesn't multiply to be 6x squared. And he said, no, it's okay. I'm going to put a 6 in both cases. And I said, all right, but 6 times 6 does not multiply to 6 squared. And he said, wait, I'm not done yet. Then I'm going to divide each of those parentheses by any common factors they might have. So that first parenthesis has a common factor of 3. He's divided out by that to give us 2x minus 5. And the second parenthesis has a common factor of 2. Divide by the 2, we get 3x plus 2, which is our 6x squared minus 11x minus 10. So it's taking that idea of that x, those prefactoring puzzles, and just taking it to a new step. And Cole realized this on his own. So putting that, whatever that leading coefficient in, is putting that into the parentheses, and then dividing out by common factors allows us to get down to the prime factorization of that polynomial. So again, we call it Fitzy's method. I don't know if that helps or not. It's kind of fun and easy, and it just follows through on that prefactoring puzzle idea. All right, hope that helps. Bye-bye.